Hi guys, I'm Sai. I'll be teaching you scripting. Till now you heard from Vishav. He gave you a bit of introduction into vectors and explained you how a MATLAB looks like, all the interface and all the key components of it. So scripting is basically a set of instructions, how you communicate with MATLAB, telling it what to do and how to do it. So MATLAB is used for many things actually, but as we are focused on teaching you how to use MATLAB in day-to-day engineering life and training you to work on numerical models in future, I would be teaching you scripting using an example of a basic physics problem, and I'm doing this because you would be using MATLAB purely to solve numerical sums in your MATLAB in your engineering life, and this will give you a better idea on how to go about telling MATLAB how to solve an equation and what you want out of it and how you want to manipulate data and everything. So let's begin with the example then. Imagine you are in a hot air balloon and you are at a height of 500 meters and you drop a rock, and we would assume there is no air atmosphere present there, and so hence we would be ignoring the air drag. The only force acting on the rock will be gravity. So how would you solve it in a normal life? You would solve it looking at all the initial conditions. You know the initial condition is 0, initial velocity is 0, and the gravity is 9.8. Gravity acts as acceleration, which is 9.8 meters per second square, and you know the time. Let's assume we want to calculate the distance the rock traveled in 10 seconds and the velocity at 10-second mark. So we would just take all the initial conditions we know and put them into equations of motion here. It's a very basic equation. Distance is the function of velocity and time and acceleration, and the final velocity is also a function of initial velocity, acceleration and time. We would input all the initial conditions we know and we'll get the value of s and v, which is distance and the final velocity. So let's go to MATLAB and try and implement this for the first task. So I'm opening up my MATLAB in just a second, and here we go. So this is a script file which I already made. So which I've already explained you what the percentage marks do. The percentage marks tell MATLAB to skip that particular line, and everything in the green here is for you, not for MATLAB. This is for you, for anyone who's going to read the script, and it's for yourself. So when you come back in future, you know what this particular code is doing. I mean, like, people don't really write comments. These comments are really important. I mean, it's a very good habit for programmer or any kind of numerical solving software you write on. So I would like you to develop this habit, leaving comments in each and every script file, so that you know what the script file is for. Okay, with no further ado, let's jump into solving the problem. So here, the double percentage marks, these actually divide the script file into various parts. Like with the starting here, I split the script at line number 8, and I also split the script again at line number 14. So what it does is it gives you the chance to run the script in different parts, so you can either see how the code you wrote is working, or if there are some issues, you know the issue is within this particular sector, not rather than somewhere else in the code. So in this particular subsection, I'm defining the variables, the initial conditions, to be clear. So here the initial velocity u0 is 0. So here, let me get into syntax at this point. So why to put a semicolon at the end? This normally tells a MATLAB that not to print the output in command window and just store the variable. So u0 is a variable and we assigned the value 0, and u0 here we know is the initial velocity. So let me execute this particular set of lines. So control enter, and the MATLAB is currently running these 3 lines now, and as soon as it's done, you will see it's gonna load variable values in workspace. And here now we have the gravity g value, which we defined 9.8, then the time 10 seconds, and the initial velocity u0. So let's see if I remove the semicolon, what happens. I will press Ctrl Enter again, and you can see MATLAB outputs the value of u0 here. We don't want MATLAB to output each and everything we give it as variables. This is because we know we don't want to crowd the command window with all the outputs rather than the outputs which we really want. So once we have done giving it initial conditions, then I will go and write down define the equations for MATLAB to solve. So here S is the distance traveled, and the initial velocity which we already defined, the time which we defined, and half the acceleration in time square. The time here is t, which we defined it. So we have to use the same variables which we define in the equation, or else MATLAB won't know what to input here. And the other thing is MATLAB is case sensitive. So if I make this capital U into small u, the MATLAB won't be able to recognize it. So for example, I will just run this sector of code to show you what happens if I do this. So as soon as I run the code, MATLAB should throw an error now. I mean, it's still running. So here, see, it doesn't know what u0 is here, because as we define the variable as capital U0, it only knows the capital U0. So we go back, change it to capital U0, and run the code again. So I changed the small u0 back to capital U0, and now I'm going to run it. Control Enter, and here you see MATLAB doesn't throw any more errors, and it just outputs the value of capital U, that's the velocity at 10 seconds, and the small s, that's the distance traveled at 10 seconds, just like 490 meters. Once we have this, we don't really need MATLAB to solve such a small problem, right? We can do it with hand. It would take probably like 10 seconds. You have the answers. But why would we use MATLAB to solve like such a silly problem, right? So let's make it a little complicated. Now imagine we want to get 5 values of distance and velocity at 5 different time steps between 2 seconds and 10 seconds. That way MATLAB has to calculate distance at 5 different values and velocity at 5 different values. To do this, I would like to define a vector for time with 5 points. So the way I'm doing this is the syntax. I will explain you how the syntax works, and I will also give you a little more insight into it. Okay, let's see how the vector looks like initially. So I take this TA, we are trying to create a vector with 5 points, and I will copy it and put it in, I'll copy it and put it in the command window so you guys can see how the vector looks like. Press enter, and we have a vector with 5 time steps right now. So here, what this syntax is, what we are trying to tell MATLAB is start from 2, and after this colon we give the difference between each and every time step and stop at 10 seconds. So this is the initial point, this is the last point, and this is the difference between each and every time step. So you can look here, initial, final, and this way. The other way to do, there are many ways to declare a vector, but I would give you some more examples like line space. This command, what it does is create a vector with equal spacing, and how it works is I have to give it an initial value 2, the final value 10, and the number of points I want, that's 5. As soon as I press enter, we should get a same vector like TA, which is starting at 2, ending at 10, and 10 points, which is equally spaced between them. So once we have this, how would we go about telling MATLAB that we wanted to calculate values at each and how would we go about telling MATLAB that we want values of distance and final velocity at each and every point? So let's look at the code again, the script file. So once we have the time vector, we go back to defining the final velocity vector. I redefined the final velocity from capital U to U underscore A and define the velocity equation u0 plus g into 8 TA. This TA is the vector we just defined. So let's see what happens when I tell MATLAB to do multiplication between g, the gravity which we defined, and the vector TA. So this is just for you guys to look at what MATLAB is doing. MATLAB, what it does is it does a scalar multiplication. It takes the value of g, that is 9.8, and it multiplies with each and every value of TA, that is 2. This 9.8 into 2 is 19.6. TA at second point is 4. 9.8 into 4, you get the value. 6, you get the value. And this is what this type of multiplication is known as scalar multiplication, and this is pretty common. I mean, like, if you take a scalar value and multiply with a matrix, you would take that value and multiply it with each and every element. That's how matrix multiplication works. Then, and the initial value here u naught is 0, so we already have the values of u, final velocity of u, at 5 different points here. And the same thing with the distance. So we write the whole equation, and here I define the distance as a capital S, so it can distinguish between the old small s distance at 10 seconds and the new distance at 5 different values. So u naught, initial velocity, into time, into half a t square. So now when we square a matrix, how would you tell the MATLAB that you want to square each and every element rather than multiplying two matrices with each other? One thing, you can't multiply a matrix of same size. I mean, like, you can't multiply a row vector with a row vector. You would multiply a row vector with a column vector. So as soon as I remove this dot from here, which tells MATLAB that we have to square each and every element of matrix, if I remove that particular point and try to run this code, you will see MATLAB will throw an error which says that this is not possible. We need a square matrix, or we have to do a scalar squaring. So for that, the syntax is point. We just have to put a point in front of the square operator. So once you do this, and once we do enter, we now get two vectors, that is the capital S, distance at 5 different times, and the capital UA, that is a velocity at 5 different points. Once we have this is nice and well. We got both values at 5 different points, and MATLAB does it much faster than you. You have to go through the substitution with yourself. You don't have to do it. With MATLAB, it's done in seconds. This is a very basic problem, but you can understand how complex things you can do with this kind of vector manipulations. So once we have this, now we would like to see how the whole picture, I mean, like, how the velocity increases with time, and how it and also want to see a much better visual representation of the calculation we just did. So I used a plot function here. I would like to plot it before I go into the syntax and tell you how each and every part of this plot function looks like. So control enter, and the MATLAB is going to plot it now. Now we have the plots output. So I will go through the syntax now so you can have a better idea. So the figure, this tells the MATLAB to open up a figure, an empty figure. The plot function tells that we are going to plot something in 2D to MATLAB. So the TA is the time vector we just we input it into the system, which is an x-axis here. And then the S is the distance we calculated, which is in the y-axis here. And OG, it defines the color. G defines the color, which is green, and O dot defines how it looks like, the circle and a line, circle and a line. Circle represents the calculated points, and the line is just a plot which shows connection between each and every data set. Then we get into title. Title is title is something which you give to the plot. I mean, like, a basic distance versus time is good enough for this particular plot. Then X label will tell you what X is, so you define X label time S, so this is given by U, and Y label defines what the Y axis represents here, that is distance in meters. So then the next plot is the velocity versus time. The syntax is pretty same. So as soon as I wrote figure, it opens up a new figure, then it plots it as
TA x-axis and UA is y-axis. So plot function, you define x-axis first, then the y-axis, then how you want it to look like. So dot star r will, r here is the red color which is shown here in the plots, and the star tells the MATLAB to represent each and every point as a star. Then the line space width tells the MATLAB how thick the points should be. You can make it of any size. Then the gray down is the grid black lines on the background, which are not present here because I turned off the grid on function with a star here, so MATLAB won't read it. So once I turn on the grid, it's much more easier for us to read the values and where the points are located, compared to here it's really hard to just go about not knowing where it is. So this makes life easier for us to read it much better. So once we have these two plots, we can see how the velocity is increasing with time, and here we could see how the distance is increasing with time. And as you know, here the distance is a function of at square, as initial velocity is 0. At square is a parabolic equation, and you can see with more points you could probably have a complete parabola built here. So once we have this, I would like to teach you how to find various syntaxes. Here plot function, as I explained you, I know it will be hard for you to remember and understand and recall every time how the syntax looks like. So the best way to find out how to plot things is Google it. So MATLAB has a really well built up library, which is normally a website called MathWorks. So before doing that, I would just like to tell you, okay fine, we want to create a vector TA with 5 points. So as Vishop taught you, creating a vector in a very simple manner. Okay, I will just type it here again. So before doing that, I will just clear the window so you can see it clearly. So TA, how Bishop taught you to make a vector is something like this, right? You make a square brackets and you put in values 2 space 4 space 6 space 8 space 10. So 5 values TA, and this is one way to define it. But you can do something like this for 5 to 6 points, but you can't do something like this for like 100 points or 50 points. So one way, you don't know this syntax or you don't know any other syntax. So what I would suggest is go to Google, find how to make a row vector with equal spacing in MATLAB, and you have the first suggestion from MathWorks. So you click on it, it will get to the website, and you have the complete details on how to write it, how line space works. So line space is the function keyword which you use to tell the system that you want to make equidistant vector. So x1 is the initial point, x2 is the final point, and if you don't give it the number of points you want between these two, it will just produce 100 points evenly spaced between x1 and x2. So, but what we used was this particular line here, and it will tell you how the system works, and you can read it and you can figure out which one you want to use, and it also shows the operator we were using, this colon, and how it works. So you can do the same thing for plot. If I want to say plot function, and MathWorks will give you a list where you can just go and look for what you want. See, plot 2D lines, the first one is what we used, plot 2D lines. So plot, click on it, and here you go. See, everything we used is here, so you can just read it and try and apply it in MATLAB. If you think writing a script and not knowing if it's going to work or not, that is an issue for you, then you can just try it in the command window. Try plot here and just try and see if you can plot it properly. Just write plot TA, UA, and if I press enter, it plotted, but it's just plotted over here. See, figure 4, and it plots everything. Then you know x and y and this and this. Then you go about going through a script and putting everything into it, slowly building up a plot which looks like this or this. Okay, with this I would say with this we would like to move on to practice session. So we strongly believe a best way to learn a programming language is to solve it and try it and apply it on yourself by yourself. So we will be giving you a set of questions and we will be with you for the next 1 hour where you can apply, see, try to solve it. If you are not able to solve it, you can always get in touch with us. We will help you out. And